thought it was going well, but then several students had some questions when they started working on their assignment. So I'm going to go a little slower with your class. But this lesson is just going to put together pretty much everything we've talked about. So a good portion of it is going to be repetitive, things you've seen over and over and over again. But the new stuff is kind of difficult to understand. So anyway, the new stuff we're going to learn on the front. And so part of this is old. So the part that's old is the A part, where we're going to find the equation of the secant line through the points when x is equal to -1 and when x is equal to 3. So this is what we learned yesterday. So what do we do first? Plug it in. Thank you. So we're going to plug in -1. And you are welcome to use your calculator, or we can just do it in our heads. But in this function, is that negative being squared? It is not. It would have to be in parentheses if it was being squared. So we're going to square -1, and what are we going to get? +1, and then make it negative, and then add 2 to it, and what do we get? 1. All right, same thing. We're going to square 3, make it negative, and then add 2 to it. Yes. All right. Then once you found the values, then you're going to find the slope by subtracting the y's in the numerator and the x's in the denominator. And then you have options on the last one. We can use either ordered pair. I'm just going to use the first one. It doesn't matter. So we'll do the y, and then the slope, and then x minus the x, which in this case is going to be a plus. So hopefully you feel pretty comfortable with that from yesterday. All right, and then the b and c part is the new part. And so what we're going to do on B is just draw a rough graph of this function with the secant line going through it. And so I know some points on the function. I know when x is -1, y is 1. And when x is 3, y is -7. And I know one other thing from Algebra 2. Hopefully you guys remember this, but all quadratic functions like this are going to be parabolas. Would this one open upward or downward? Downward. How do you know it's downward? The negative. So if it's a -x squared, it's going to open downward. What is that +2 going to do? Because the original parent function is at 0, 0. It's going to shift it up. So a +2, like outside of any parentheses, is going to shift it up 2. So I also know, just from previous classes, that the vertex of this parabola is going to be up at 0, 2. So I know 3 points on this. I know basically what it looks like, so I can just draw a little parabola. Does not have to be beautiful. Mine is not very symmetric, but that's okay. All right, so that's the graph. And then we also want to draw the secant line. And this is where things went wrong when my last class started doing their assignment. Your secant line has to go through those 2 points that we found the slope from. So the secant line has to go through these 2. You can't just draw a secant line anywhere you want to. It's important that it goes through those 2. There we go. All right, so that's the function with the secant line. Now C, we're going to answer some questions about other points on the graph. And so C says that is the value of the secant line greater or less than the value of f of x at x equals 1. So this is what I'm going to do. I'm going to go to where x equals 1, which is right here, and I'm going to put a point on my parabola, and I'm going to put a point on my secant line. So the question is the secant line greater than or less than the function there? What do you think? Less. Why? It seems obvious, but it wasn't obvious last class. Because it's below it. I thought that was obvious, but it's okay. It's easy to get confused when I'm going kind of fast. And I probably did. I definitely went too fast last period. All right. And then we're going to answer a couple more questions. So what about x equals 4? So x is 4. 1 over from 3. And so on my secant line, it'd be about right there. I would need to continue this one down pretty far. But it would be about right there. So is the secant line greater than or less than at 4? Greater, because the point is above the point on the original parabola. All right, and then -2 is my other point. So it's going to be here, here. So for -2, secant line is also greater. Okay, so we're going to do another one of these. If things are still kind of confusing, it's okay. Hopefully it'll click. But I want you guys to do A completely on your own for example 2. Find that secant line. I see some of you are doing the graph on your own. That's great. I'm gonna go ahead and kind of talk about it. If you can do it on your own, you can kind of tune me out. I know my voice is super easy to tune out, apparently. Okay, so I just graphed the 2 points that I found on the A part. And then this time I know this is a parabola that opens upward. And I know also that it shifted down 3. So my vertex is going to be right here. So I can just kind of draw a little parabola. All right. And then those 2 points I found on part A have to be on my secant line, or it's not a secant line. Okay. And if you get that graph right, the next 3 questions you should be able to do okay. Just remember, when the point is above, it's going to be greater. If it's below, it's going to be less. So for C, they're asking about 0. And so on the secant line, that's where my 0 is. And then on the parabola, that's where it is. So what do you guys think? Is the secant line greater or less there? Greater. Because it is above it. All right, so I would say -2 would be about right here. There it is on my parabola. There it is on my secant line. This time, the secant line is less. And then 3. We're talking here. And then I would need to continue this up for a while. All right. It's another situation where the secant line is less. Okay, does that make sense? Ish. You'll know when you start doing your assignment, and you should have time, so if you have a question when you start doing it. Last class they were all kind of working together. You can do that, or you can ask me, whatever. But just draw it with the right shape. Draw your secant line through the points it's supposed to go through, and then you should be able to tell. There is a rule, though. I don't necessarily expect you to memorize this rule. You can. It'll make it easier if you do. But for me, I still just draw it and just look and see which one's higher. But the rule is, when a graph is concave up on an interval from A to B, and the secant line through A and B, so this is A and this is B. So the secant line through AB is going to give a greater value than the original function anytime that the value falls in between that interval or inside that interval. Because if you look, inside, the secant line is higher than the original function. All right, and then outside A and B, the original function is higher than the secant line. So it's going to give a less value when it falls outside of the interval. And then concave down is just the opposite, because that's what we got here. The original one was concave down. We got less, greater, greater. And then we have concave up, and we got greater, less, less. So it's just going to be the opposite. So you can draw your secant line however you want to, as long as it's going through A and B. All right, this time the secant line is greater than the original function whenever the value falls outside of the interval. And it's less than the original function when it falls inside the interval. So I know sometimes it's hard to listen and write at the same time. So I'll say that again. So concave up, the secant line is greater on the inside of the interval because this is higher than this. And then the secant line is less than on the outside because that line falls below the original function. And then opposite here. So the secant line is greater on the outside because that's above. Secant line's above. And then less on the inside. Okay, now I know you guys are probably getting tired about these same problems about equal length input value intervals, but we're going to do it again. So this problem is about people exercising at the gym. So the table gives the number of people that are exercising in a large gym. T equals 0 corresponds when the gym opens at 7 a.m. T responds to the number of hours, or the number of hours that have passed since the gym opened. And this table gives the number of people during those hours. All right, so A1, we're going to use the table of values to determine if n is best modeled by linear, quadratic, or neither. So how do we do that? First and second differences. So we're just going to take one and subtract the previous one. So if you guys haven't done that already, go ahead and take one, subtract the previous one. If they're not, the first differences aren't equal, then you'll need to do it again. So on part A1, if you just write quadratic function, you'll still get your points. But the best practice is to write it as a sentence, answering the question. All right, and then we'll see if together we can get this reasoning. So how do we start off with our reason? The second difference is good. What are they the differences of? Good. All right, and then what are these second differences? A constant 4. All right, tell me about these input values. Good job. Part 3 is new. Now you've done this, but we've never done this on like a free response type situation. So number 3 asks, is the function that models the table concave up, concave down, or neither? Now we know it's a quadratic, and a quadratic is going to be up or down. If it had been linear, it's going to be neither, because linear doesn't have concavity. But this one is either going to be concave up or concave down. What do you guys think? Up. Why?
Differences are positive.
The change in the differences is positive or increasing. So the best wording is not don't even use differences on this one. We didn't find the average rate of change, but if we did, how is the x changing each time? Just 1. So it would just be like divided by 1, divided by 1. So that would be exactly the same. So we're going to call them average rates of change. Because that's the definition of concave up, or that's part of the definition. So N of t is concave up because the average rates of change are increasing. So going from negative 20 to negative 16 to negative 12, that's getting larger every time. So this is going to be one of the parabolas that's concave up. Okay, the next page is the same problem. So I just redid it, same wording. We're going to answer totally different questions though. So for B1, we're going to use the data to find the average rate of change in the number of people exercising from t equals 1 to t equals 4. So even though there's all these other numbers there, those are the only ones we care about. If it doesn't come out even, we are going to give a decimal approximation, not a fraction, and then we're going to show everything. All right, so what are we going to subtract in the numerator? Thank you. So 28 minus 64 in the numerator, 4 minus 1 in the denominator. This is a calculator question. You can do this in the calculator or in your head, but you would get negative 36 divided by 3 or negative 12. Now you are not technically responsible for putting the unit on this, but I want us to because it's going to help us answer the next question. So what would the unit of this rate of change be? Very good. People per hour. Because we subtracted people in the numerator and subtracted hours in the denominator. All right, and again, from previous lessons, we're going to interpret the meaning of that. So between what times are we talking about here? Good. T equals 1 and t equals 4 hours. What is changing? Very good. The amount of people exercising right. Would you guys say the amount of people is increasing or decreasing? Decreasing. Because a negative rate of change is going to mean that the amount of people is decreasing by 12 people each hour. Okay. And the number 3 is also from yesterday. We're going to use that average rate of change we just found to estimate the number of people exercising at t equals 6. So I'm going to go ahead and write a secant line. And I'm just going to use the 164. The other one will give you the exact same answer. All right, and then we're going to plug in 6. Okay, so it looks like we get 64 minus 60. All right, and then part 4 is the new question. And I worded it very much like the AP exam from last year. I'll get results back, like how my students did, and I only got one person get the point on the question that was like this. So this year I decided I was really going to focus on the secant line stuff and make sure that more than one person gets this right next year. So we are going to let E represent the estimate of the number of people exercising in the gym using the average rated change we just found in 1. So basically using this equation, that's going to now be called E. All right. Is E of 6 found in part 3? Oh, there's a little typo right there. Less than or greater than the value of N of 6, which is going to use the best model. So N of 6 is going to be that quadratic model from this page, and E of 6 is going to be this line we just found. So this is what I would do if I was you. And I graded this question, so I know what the graders are going to look for. If you draw a concave up quadratic, so if this is a quadratic function, which we said it was, if it's concave up, which we said it was, if you draw that, and then draw a secant line through it, now I would kind of, it doesn't have to be super accurate, but if we said that the average rate of change was negative on the secant line, I would probably draw one with a negative average rate of change. All right, and then I would label these intersection points. What should they be for our secant line? Where should they? Thank you for a positive one, yes. All right, they have to match up with the points we use to find the slope. If they don't, then we've drawn it wrong and we can't really answer questions about it. Okay, so the question is E of 6 going to be less than or greater than N of 6? And so this secant line is E. So is the 6 going to fall in between our 1 and 4 or outside? Yeah, it's going to be like right here. And we would need to continue that up. So what do you think? Is E of 6 less than or greater than N of 6? Less, because it's below. All right, so let's get this wording right. So answer the question like you just said. E of 6 is less than N of 6. But that's definitely not enough for you to get the answer or get the point. When you give the reason, it needs to include that E is a secant line and that N is concave up. Sometimes the drawing is enough, sometimes it's not. We're just going to pretend like it's not. So the reason is because E of t is the secant line of N of t through t equals 1 and t equals 4. That's important. You include all that. Labeling it on the graph is good, but it's also good to mention them just in case you forget the label. All right, and then because we have to mention the concavity of N of t is concave up. E of t will fall below N of t when t equals 6. All right, now it's going to be hard for you to get that wording exactly like that. Like, this is the perfect wording. It's okay. When you're taking a test, just try your best to include all those things. I know what to look for, whether or not to give you your point, but we're going to practice perfection as much as we can. All right, what questions do you guys have? Okay.